Any questions on either finding the coordinates of points that are already graphed or actually finding the position of points on a coordinate plane based on their coordinates? Any questions at all? Anything? Okay, the next thing we're doing here. All right, the next thing is the relationship between two variables. In this case, we're calling them y and x. And a lot of the context of what we're going to do in our class, like the very first project that you're going to be doing for Friday that I handed out on last Friday. And if you were not here, you'll want to pick up one of these green sheets at the end of class. Is that often the variables will have names and other letters other than y and x. But this is sort of your typical equation that you learn to graph with y for the dependent or vertical variable and x for your independent or your horizontal variable. So it looks like everybody did a great job. The only thing I want to do here is to add this point, -3, -5. And if we plotted those points, what does each of these individual points actually represent in terms of that equation? The points themselves are not a parabola. Like one of these points, I'll take this point, 1, 3. What does that represent in terms of that equation right there, 1, 3? Yes, it's a solution. It's one possible solution. So each of these 7 points represents a possible solution to that equation. What do we mean when we use the word solution? That if I put 1 in for x and square it, subtract that from 4, I will come out with 3, and that the left side equals the right side. That's what we call a solution to an equation. So these 7 individual points represent 7 different solutions. How many solutions do I have to this equation? Infinite. So how do we represent this infinite solution set with a picture? What would I do to represent all possible values of x and y that satisfies this equation? What would I now do with these 7 now that I kind of have a shape going on? I would draw a parabola. In other words, I would take each of these, I would start down here, and I would connect these points with a smooth curve, not with straight lines, a nice smooth curve. This is my highest value, and then I come back down like this. Notice it doesn't have any gaps in it or holes or jumps. It's a nice, smooth, continuous curve, which means I could continue that in that shape without taking my pen off my paper or my pencil, depending on what you have. Until the paper ends, right? So anytime you have a graph of an equation, you'll always want to label that graph with its appropriate equation. This is like putting a title on it. So I never want to look at a graph in this class without seeing its equation. Okay, that tells me everything I need to know about that picture. So based on this picture and this particular equation, can someone else who hasn't already had a chance to contribute to the class tell me something else about either the shape? We already heard the name of the shape. I'm sorry, what was your name again, Alex? No, yeah, Victor, sorry. Parabola. It's Victor's first day, so I'm excused for not knowing his name. Okay, so anytime we have a shape like this, it's called a parabola. What do you know about the equation that gives us a parabola? What can you tell me about the equation that gives you the shape? Yep, Ira? It's quadratic. What does it mean for it to be quadratic? So that's correct, it's quadratic. This is called a quadratic equation. How do I know it's quadratic? And what about the second degree? If I had something like this is second degree, or this has a second degree, but would this be quadratic? It has an x square in there. So what about the second degree? The second is the highest, right? It's the highest power you see, right? So second degree was correct, and it's the highest power or degree you see. Okay, so you don't see any x cubes or anything higher than x squared, and that tells you your shape of your graph will be parabola. Why is this a sad parabola with its arms going down, down, down? The x squared part is negative. Maybe. Maybe. I'm really picky when it comes to language. You know, you'll learn that about me. The x squared part is negative. First of all, yep, we used all of them. Yeah, sorry. So Ian says the x, this took my first class like 10 minutes for me to like get this out of them. So just know that we're going to be working on language. X squared part is negative. Well, remember we called the part a term, right? So remember these pieces, the pieces of an addition and subtraction problem were called terms. So remember x squared, can x squared ever be negative? Can x squared ever be a negative number? Well, can x squared ever be a negative number? I'm turning you off, Ian. Okay? I'm going to try to get the rest of the class to. No, x squared can never be negative. Can it be 0? Yep. So x squared is a non-negative number. In other words, x squared is always greater than or equal to 0, right? That's an inequality that could represent that. So the x squared part isn't negative. So Ian can't say anything now. So we want to edit this. Let's edit this because he's got a really good start going for us, Ian does. So what do we want to say here? How do we know? Yeah, Ben? The operator, well, what's the operator is subtraction. That's the operation. Okay, so could I write this some other way, like as an addition problem, Ben? Okay, so I could just turn it around and call this negative, or the opposite of x squared, which is how I prefer to say it, the opposite of x squared plus 4. Or what's the number multiplying x squared? What's the number multiplying x squared right now? -1, right. What is -1 called? Coefficient. So the coefficient of x squared part, so we're now going to edit what Ian said, the coefficient of x squared is negative. And that's what makes this parabola open downward. Okay, so that's the language. And that's the language you'll be hearing me use. So it's really important that you know what I mean by coefficient. Okay. If I'm up here using language and you have no idea what it's about, then you're not going to really be getting the full benefit, right? And if you don't read your textbook to learn what some of this vocabulary is, then you're not getting the full benefit. So please help yourself as a student. You'll be coming across lots of new ideas and terms. And I used to always recommend that at the end of your class notes to jot down new things, new terms, new words that you've heard in class, so that you can just remind yourself as you go back to review for quizzes and tests and just your general understanding. So that's what makes this a downward shaped parabola. What else can you tell me about this parabola other than it's opening downward? What else can you tell me if you haven't already had a chance to show me all your brilliant ideas that you have? What else can you tell me about this parabola? Yeah, Kelsey? Okay, so it's, I know what you're saying. So if we pick on this point right here. This point is 1 unit to the right. We're not going to go to another point with a totally different x value. What are we going to go to? To its opposite value. So the opposite of 1 is also 1 unit to the left. That's what makes something, in this case, equidistant from 0. That's what makes you an opposite. So Kelsey's noticing that if I take opposite x values, I arrive at exactly the same y values. That's a really key feature of this parabola. Opposite x values give us the same y value. This has a really fancy name in mathematics that we're going to explore later on in a few classes. And what did you say, Claudia? Right. So, right. So Claudia is saying that this line, which we call the y-axis, and the equation for the y-axis is x equals 0 because every single point on the y-axis has an x value of 0. So the equation for the y-axis is x equals 0. So what Claudia says is that the equation, or the x-axis, or the line x equals 0, which we famously call our y-axis, is the line of symmetry. And it's the line of symmetry for exactly the reason that Kelsey noticed, because if I walk a certain distance x to one side of the y-axis and I walk the same distance to the other side of the y-axis, I'm at exactly the same y value. So that's called even symmetry. This parabola has even symmetry, and we're going to, like I said, we're going to be talking about this in more detail. And even symmetry means that your line of symmetry is the y-axis, that you could fold this parabola right along the y-axis and make a crease, and you'll have the points sitting on top of each other that are the same distance from the y-axis. That's sort of like kind of a intuitive way to talk about it versus an algebraic way. So we're gonna talk about what would be the algebraic way to do a test to see if any equation would have even symmetry without its picture. All right, that's later. I think that's enough for this parabola. Let's take a look at today's teaching demo. And before we get to using our graphing calculators, let's review what the intercepts of a graph mean. And Sam, you want to start us off with finding the x and y intercepts of a graph? Term intercept, x-intercept of y, or y-intercept. This idea of the graph crossing that axis, I can't help it, but I think of football and interceptions. And the Patriots, did they have any interceptions last night? They had 2 fumbles, but I don't think there were any interceptions. So if you're not a football fan, in football, if you're trying to pass the ball to someone on your team and the other team gets in the way, like one of the axes gets in the way and takes the ball, that's called an interception. So I don't memorize how to find these things. I always just visualize that an x-intercept is a point that's sitting along my x-axis, and if I'm sitting on that x-axis, my y value is 0. So I just always start off by putting a 0 where y is. I don't memorize it. I literally just visualize it. So if we go back to our parabola that we set up for ourselves right here, that we drew a few minutes ago, and I'll try to capture it and put it on this page for us with all this writing. So if we capture that parabola, I'm surprised it didn't make a sound, which makes me think I'm not recording. Looks like I'm recording. Hopefully I am. Let's get that. Let's cut it and put it on the next page, right next to what we're doing. Paste. Let's make it smaller. As you go to your x-axis and you see what are the x values that have y equal to 0, and what are the 2 x values that have y equal to 0 here? -2 and +2. So -2, 0 and +2, 0 are the x-intercepts. Note you have 2 x-intercepts. Note 2 x-intercepts, which tells you that when you set this equation, y equal to 0, you're going to have 2 solutions. You're going to have 2 values of x that make y equal 0. And that's the kind of thing you always got to keep in mind, because you can always forget one of the x-intercepts. And I'll show you why you do that, or why traditionally students do that. And what about the coordinates for the y-intercept? Ayanda, can you help me with that? 0,4. Thank you. So that's 0,4 is the y-intercept, -2, 0, and 2, 0 for the x-intercepts. So if you have the graph right in front of you, then all you have to do is find the appropriate coordinates. And I will always ask you for the coordinates of the x and y intercept. So on your project, when I'm asking you for an intercept, don't just put 2 and -2. I'm always wanting the coordinates. I'll always ask you for the coordinates on any type of assessment. Okay? Even if the book says that the y-intercept is 4. Let the book say that. When I ask you for a y-intercept, I want you to say parentheses 0, 4 parentheses. All right, so how do we find the x-intercepts algebraically? Well, right now we have an equation that has an infinite number of solutions. I'm only interested in the solutions that give me y equals 0. That's all I'm interested in for the x-intercepts. So I set y equal to 0. That's the first thing I do. And I get 0 equals 4 minus x squared. And now I have to figure out how to solve this quadratic equation, this baby quadratic equation. I don't know why I'm calling it a baby. Maybe because it doesn't have all 3 terms in it. It has your squared term and it has your constant term. All right, so how do I solve this? Someone want to help me solve this? I'm just going to go to the next page and solve this. Eric's already talked and Ian's already talked, and who hasn't helped me out today? Have you helped us out? Oh, I'm forgetting. Let's see, I've got Molly and I've got Paige and I've got, help me, Angela. Can you help me solve that? Yep, okay. So you want to do 0 equals negative x squared plus 4? Okay. Okay, subtract 4 from each side. Okay, you're all set, Angela. Where would you go from here, Molly? And you always have the option of passing. So just let me tell you that. You can always say pass, and I'll just move along. Oh, okay. Well, let's start with that one. There's going to be several different ways of doing this. So Molly says, I just factored it. Just factored it. Yeah, no problem. We just all factor. How are you going to factor that, Molly? Almost. If you do x minus 2 and x plus 2, that gives you x squared minus 4. We don't have x squared. Notice your numbers first here, right? So it's got to be 2 here and 2 here. And then your minus x and your plus x, okay? That's different, a little bit different, okay? But that's good. I was hoping someone would say they'd factor. We'll get to there in a minute. Let's continue with this. Can someone continue with this, Alex, this method here? What would you do? By what? By x? Negative x. Okay, so if I divide both sides by negative x, I get 4 over x here, and I get x there. Yuck! I don't like that. Kelsey? Take the square root of negative x squared? Oh, no. See? You see how oh, divide everything. All right, well, I'm getting all confused here. I'm getting all different answers. All right. So first of all, what is it that we want? We always want the coefficient. Remember coefficient in front of x squared to be 1. And right now, what's the coefficient? -1. So to make it a 1, we have to divide or multiply, whichever you prefer, by -1 on both sides. So now we have 4, and now we have x squared. Phew, we got that far. All right. Now what? Take the square root. That language gets us into trouble because take the square root implies how many answers? Take the square root implies 1 answer because it's singular. Doesn't it? If I left you to your own devices, how many people would have just done this? And I'm going to erase it the minute I do it. Most students do this. Most students do that. And then most students do that. And they're so thrilled with themselves. You only got one of the x-intercepts, right? We had the -1. And you were allowed to do this along the way. It's not your fault. You were allowed to do this. there are two values of x that you can square to get a positive 4. So let me show you really what's going on in here that you were never asked to do by your math teacher along the way. And this goes back to recognizing that this symbol is only asking you to find the positive square root. So this is really saying, what is the positive square root of 4, which is 2? And this is asking you to find the positive value. I know x could be x or the opposite of x. I can do this. The opposite of x squared equals x squared, and x squared equals x. So if this is just indicating that what comes out of here has to be positive, I have to do that. And you were never, ever asked to make this statement. The square root, the positive square root of x squared, must represent a positive value. And the only way we have of ensuring that a variable is positive is putting those absolute values right there. This is a huge leap right here for some of us. Now you look at this equation and you say, hey, I got two numbers whose absolute value, its distance from 0 is 2, -2 and +2. If you were trained to do this, then you would know that you have two answers for that equation, the absolute value of x equals 2. But you weren't. Some of you were taught that when you do this, you have to put a plus and minus there. I guess that's okay, yeah. But most of us just use that little square root symbol, and we always lose half of our solutions to the equation for intercepts. So the surefire way of doing this so that you don't miss one of them is to factor it. And anytime you have a constant like this and your quadratic term with a subtraction in there, factoring is so easy. All you do is take the square root of the number, and in this case, because the number is first, you put it in the first spot in your binomial factors. Then you take the square root here, x, and you put a plus and a minus. And now to finish it off, what do? You say, to finish this off, this is now turned into a multiplication problem. So if I multiply two numbers or two quantities and I get a 0, what does that tell us? It tells us that this must equal 0 or this must equal 0. So if I find the two values of x that makes either one of those factors 0, I've got my solution. So this is two baby linear equations to solve. X equals -2, x equals 2, and again, you won't forget that it has two answers. Okay? So this is one of those little bugaboos, equations like this, quadratic equations like this, students often forget two answers. So do whatever you need to do on your class notes right now, whatever symbols you want to use, notes you want to use. If you have a tendency to do this, try to remind yourself. Eric? Sure. At what stage? Absolute value here? Yes, because the absolute value can never be -2. Only x can be -2. Okay? It's the absolute value that ensures you're taking the positive square root of x squared. All right, so let's take a look at what else are we doing here. We're going to see how to use those graphing calculators I just gave you. Oh, and to find the y-intercept, what do? The y-intercept, your x is 0. So that's the easy one to find, y equals 4. So it's 0, 4. Okay. So pull out your graphing calculators that I gave you. Some of you will have 84s and some of you will have 83 pluses. It doesn't matter. Let's see how we would learn to graph this parabola that we just looked at on a graphing calculator. So I have a TI-83 right here. So the first thing you need to do, if you've never used these before, is to learn how to turn them on. So you have your little on button. Where is your on button? Let's see. Down here in the left-hand corner. Boom, you're on. Oops, I got to take away what I did in the first class. All right. One thing you want to look for when you hit your y equals button, because this is where you will y equals, you want to graph y equals, make sure up here where it says plot 1, plot 2, and plot 3, that none of those are highlighted, because if they are, you're going to have trouble graphing. If you do, let me know and I'll come around and help as soon as I get everybody going here. Okay, so you put in exactly what you see here, 4, and it says 4 take away x squared. There's two ways you can do x squared. You come to this little button right here. It has the x and the theta and the n. You just hit that and there's your x. You can either just square it right now, or you can say, here's my little caret that raises it to the exponent I'm interested in, caret 2. So that's how you can write 4 take away x squared. We all set there? All right, so we've done step 1 and we've done step 2. We've entered our equation into y1. Now we want to graph it. So let's graph it. You hit the graph button right here. Oops, I forgot I have my window changed from the last class. Let me just go back in here. Yeah. And I'll explain this in a minute. Okay, so let's graph that. And voila, you will see a graph very similar to what we just graphed by hand a few minutes ago. Okay, so let's put that right there on our paper. So no surprises, I hope. That looks a lot like. Now I just did something. Question over there? Any questions? Okay. Oh, okay. That's because you have a different window. Some of you, the students, and so this is what I want to show you. The students from the previous class had windows in there so you couldn't see it. How do you choose a window for an equation? Sometimes that's the trickiest part. If you can't see it, it's because it's putting scales on the x and y axis that's not showing your particular graph. So in other words, to graph this one, we want to use what's called the standard window. And this is how you write the standard window. This is the notation right here. So notice it says negative 10, comma 10, comma 1 by negative 10, comma 10, comma 1. And to make sure that you have that standard window, and I'll explain what that is, go to your calculator and hit the little button that says window. Okay, so the very first thing you see in your window is the minimum value for x. The very first thing you see in this notation also corresponds to the minimum value of x. So that tells you that if you look to the far left here on your graph, that value is negative 10. Okay. Then it says x maximum. So the next number that you see right here is the x maximum value, which means to the far right on your graph, that's the maximum value for x. And then it says to move from negative 10 to 10, we're going to move as we normally think we move. We don't think we move by, increments of 0.345. We normally think of our integers. We increase by 1. Our increments are 1, our change in x is 1, and that's what this x scale means. It means as I move from one number to the next, I'm increasing by 1. So I go negative 10, negative 9, 0, 1, 2, up to 10. Okay? The next part of my window is my y minimum value. So this is y minimum is 10. That's down here, negative 10. My y max is 10. And my scale increases or decreases by 1 as well. So this number here is the change in your y value. The change in my y value is 1. The change in my x value is 1. That little triangle that I just used, that little triangle means change in. It's called delta. It's a Greek letter. That's how the Greeks write a small capital D, or what might be equivalent to D in our alphabet, delta. And it means change in. Change in. So the change in my x value is 1. That's what this number means here, and the change in my y value is 1. So you should be able to see this graph on your calculator if you have that window. So has everybody been able to get this graph on their calculator? No? Okay, let me take a quick peek. Which I always leave it at 1. I don't know even what I could change it to. I mean, I could look in the manual. I just never bother with it. Okay. For the data that we had in the bar graph for class number 2. So go back to class number 2, which is what page, for those of you who are famous with the pages. What page is class number 2? Page 5. So go back to page 5. Here is your bar graph. And if I wanted to graph this, what model were we using to graph this? We were using this model right here. T equals 4x squared plus 341x plus 3194. So T is now going to be called Y. So if we were trying to graph this, we go into our graphing calculator. And I need to turn off this first parabola or else I'm going to have 2 pictures. So there's 2 ways to turn it off. You can just clear it all out. Or what else could you do? See how the cursor is black over the equal sign? You can just take this white arrow, go back 1 space and hit enter. Now it's turned off. And you can just come down to Y2. So what's the model we used for that? It was 4x squared plus 341 plus 3194. But before I graph this, remember, if I graph it right now, what am I going to see with the standard window? Nothing. I won't see anything. Let's take a look. I ask it to graph that equation, just a blank, because x values going from -10 to 10. First of all, we don't have any x values right now in that bar graph, any negative x values. And what's the first tuition? $3,362, something like that. Is that the first value for my tuition at year 2000? So this highest value here is 10, so I can't see it. So I have to change my window. So let's change the window. All right, so let's look at this picture here. And I want to change my window so I can see this as a graph, the 4x squared plus 341x plus 3194. So what am I going to change my window to? Let's go to the window. The first value for my x minimum is going to be what? What's the first value for x going to be? For x is along here, and remember it was years after 2000, so my first x value will be 0 because it's just the year ending in each one of these. So 0, 1, 2, 3 up to 10. So my x minimum value is 0. I'm going as high as 10 for the year 2010, and I'm going year by year. My x scale is 1. Okay, what's my smallest y value given that I have a break in this axis here? What's my smallest y value that I could put in there? There's several different answers, but let's try to look at the way it has a scale right now. So what's the smallest y value? 3,000. So let's put 3,000 in. And the largest y value here is 7,400, right? And what are my increments along my y scale now? Yeah, they're not going by $1 from dollar, they're going by $400. Okay, so now I have my equation in there and I have my window set. When I hit graph, I should see this graph. Ooh, that doesn't look very nice. Oh. What did I forget? Oh, when I put in my equation. Oh, I forgot my x in there, right? So, if you get something, you got to look back at what you're asking it to graph. So this is where you use your little insert button. So your insert button is right above the delete button, second insert, and it's gonna let me put an x in there. And now I'm all set to graph, and there we go. Okay. It looks like a straight line because we've zoomed in a little bit. Okay. So you have to, when you think about every equation that you're going to put into your graphing calculator, the hardest part is just making sure you have the right window. And sometimes it takes just a little bit of fooling around with it and getting it so that you can see it. You have to look at your equation and think about smallest values, largest values, where your scales are. It just takes a little practice and a little willingness to experiment. Okay, how would I graph this with GeoGebra, which is what you're going to be using for your project on Friday? Well, here it is for my last class, but let me open up a brand new thing so I can show you from the beginning. Don't save. All right, so here's your GeoGebra. People are talking right now. Thank you. And notice you will have different screens available to you. You have your algebra screen on the right-hand side, your graphics screen in the middle. And remember the other day with the tuition, we were able to input the year and the tuition. To get that spreadsheet, you go up here to view and you come down to spreadsheet, and it allows you to put in the different values here for your data. Let me show you a little trick. Some of you might like this, some of you don't care. That's fine. 0. Now, most of you will just go like this, 0, and then you'll hit 1, and then you hit 2, and you hit 3 all the way up to 10. But if you remember how a spreadsheet works, you can put in a little formula here. You can say the number that goes into the second cell here is equal to my first cell, A1, plus 1. And there's my 1. And now all I have to do is take that and make sure it's highlighted blue, grab the right-hand corner, zoop, one more, 11 pieces of data, and there's 0 to 10. Okay, I can't do that with the tuition because the tuition doesn't follow a formula. Each year is different. So you then have to go in here. Is it 3,062? Like that? Is that the first tuition? Yeah, okay. So this is the type of thing you'll be doing to input the data in your project, okay? And you'll be led to all of what you need. But right now, for graphing 4 minus x squared, I don't need a spreadsheet. So I'm going to take the spreadsheet out. It just disappears. I kind of like this to be a little more symmetrical, so I take this 4 headed arrow and I have my hand and I can move it around. I want it to go from negative 10 to 10, so I just take my axes like this, negative 10 to 10. That one spreads it that way, so I move it a little bit. There we go. And this one's going to come down a little bit, and this will move up a little bit, and this will go like, you can just do whatever you want, okay? So I want to plot that. The input bar is down here in the left-hand corner. I actually used a GeoGebra the other day, another version of GeoGebra that now puts the input bar on the very top, like right here. So just be aware of whatever version you have. Your GeoGebra reference sheet will talk about the input bar being down here. My version that the guys put on in July or August was still the older version that has the input bar down there. So just know it could be in 1 or 2 places. You go like this, y equals 4 take away x squared. There's your parabola. You can move it around. Okay. Notice everything you plot, every equation that you have in GeoGebra is called an object. This particular object is called C. Notice the C appears right there. Thing I don't like about this is every time you graph an equation, you want the equation. You want to know what is being described. So this is going to be your favorite key to use. Okay, you come over here to the arrow, you click on your parabola, you right click and go down to object properties. Why is it called object properties? Because that parabola is an object. You click on it and it allows you to do a lot of different things. Notice right now the name of this object is C, its value is the equation, and right now it's only showing the name C. I want it to show the name and the value, and voila, there's the name and there's the equation, but really I'm only interested in the value, and there's the equation. If you want to change the color, again, you've right-clicked, you can go here and change the color to some lime green. You could make it really thick. You could make it like dashed, whatever suits your fancy here. And last but not least, what else can you do? Yeah, that's about all you need to know right now. Everything else you need to know. Oh, the other thing, if you wanted to give this a title, which is kind of silly, you would use a text box right here. So you just go like that. Oh, the equation. Oh, I know what I could call this. The standard parabola shifted up 4 units. You'll be learning this in about 3 or 4 weeks. And there's my title. If you want to make it bigger, you can make it bigger. You can do all types of things. That's your intro to GeoGebra. Right now you have 20 minutes to get going on your class activities. Please raise your hand if you have any questions. Not raise your hand, put up your flag. I'll come running to your side and help you